Sorry, I got cut off from that last video there. So notice 3 sets of our y's canceled out. Also, we can talk about 16 divided by 16 is also just 1. So what am I left with here? I'm left with y times y on the top of my fraction, which can just turn into y squared over 1, which is really just y squared. And that makes sense, if we look at it with the rule, because if we have y to the 5th divided by y to the 3rd, top minus bottom, 5 minus 3 gives me that 2 that I had left over with. All right, example number 6. Okay, so here, 8 and 10, neither of those have exponents. X to the 3rd and y to the 3rd. Well, I definitely don't have same bases there. Those are not same bases. But however, there is a little bit of simplifying I can do. I can't simplify the x to the 3rd and the y to the 3rd because they don't have the same bases, but I can simplify that 8 over 10. Something can divide both 8 and 10 evenly. I'm going to divide both 8 and 10. I'm going to make a little note here that tells us to don't forget to simplify the regular numbers too. That 8 divided by 10, I can simplify that. 8 divided by 10 is really, I can divide both of those by 2, is really the same as 4/5. So my final simplified answer would just turn into 4/5 x to the 3rd on top, y to the 3rd on the bottom. So don't forget to simplify those irregular numbers, that 8 and that 10. Right, example number 7. Ooh, here we have a negative exponent. So these negative exponents, you want to deal with those first. Let's make a note of that. Deal with negative exponent first. So remembering from however many lessons ago where we talked about negative exponents, we can't have negative exponents. We don't want them. We want them to be positive. So I need to switch the placement of my variable then. Those negative exponents are located on the bottom of my fraction right now. That x to the negative 6 is on the bottom. On bottom. So I'm going to move it to the top so I can make it positive. Nothing else has the negative exponent, so nothing else is going to move. Everything else is staying where it is. The only thing that's going to move is that x to the 6th. So I still have 20x to the 4th up top. I still have 5 on the bottom because that does not have the exponent and it does not need to move. And now when I move that x to the negative 6 to the top, that negative exponent becomes positive. Okay, let's do a little bit more simplifying here. We can use our multiplication rules. X to the 4th times x to the 6th. That's, x times x times x 4 times, x times x times x 6 times, giving me a total of x to the 10th. And then again, like we talked about in our last example, don't forget to simplify those numbers. A fraction represents what operation? Division. Good job. 20 divided by 5, if I plug that in my calculator, 20 divide 5 would be 4. Or if you think about it in terms of simplifying, 20 divided by 5, both of those can be divided by 5, giving me that 4 over 1, which is just 4. So final answer, 4x to the 10th power. All right, getting a little bit more complicated as we move on here. Example 8, you can see we have lots of different things going on here. No big deal, just take it piece by piece. Actually, I want to back up for a second and I want to go back to this example because I wanted to talk about how this works with the rule. If I'm looking at that rule here, I did x to the fourth. My division rule says that I'm subtracting top minus bottom. So top is 4 minus bottom is negative 6. 4 minus negative 6 turns into that x to the 10th. So you could get that same answer either way. Okay, so now moving on to x example 8. Again, start with those negative exponents first. You don't have to, though. You can deal with the 45 and the 5 first if that's jumping out at you. Okay. So I have a negative exponent of a to the third on the top. So to make that positive, I'm going to move it to the bottom. I have a negative exponent of b to the negative 1 on the bottom. To make that positive, I'm going to move that to the top. And again, all I'm doing here is moving my negative exponents to make positive. Make them positive would be better English. So I now have, well, let's deal with that 45 and 5 because why not? 45 divided by 5. Both of those pieces are divisible by 5. Gives me 9 over 1, or just 9. Okay, so that 9 is over 1. That 9's on the top. So now I have 9 fraction bar. So a to the negative 3 is going to go down to the bottom now, where it becomes positive. On the top, I still have b to the 9th. That's not changing because that b has a positive exponent. Okay, on the bottom, I have 1, which I can write. A squared stays on the bottom because that's positive. B to the negative 1, though, moves to the top. And when it moves to the top, it becomes positive. Okay, so now I can do a little bit of simplifying like we did in our previous ones. B to the 9th times another b is just 9b to the 10th. And on the bottom, a to the 3rd times a to the 2nd is just a to the 5th. Nothing else in this expression has like bases. I've got a base of b and a base of a and a base of 9. None of those match. So I'm good to go. I'm just taking a look at your practice problems. Okay. Example number 9, last one. So this one's kind of sketchy because it actually works out really nice. Well, looking at our numbers first, 42 divided by 7. 42 divided by 7 is 6 over 1. All right, both of those pieces are divisible by 7. So I've got 6 over 1, and now let's expand. On the top, I have g times g times g times g times another g. On the bottom, g times g times g times g times another g. G divided by g is 1. G divided by g is 1. G divided by g is 1. 1 times 1 times 1 times 1 times 6 gives you a final answer of just 6. So use those rules, help you to simplify and submit your practice problems for checking.